Hello, welcome to Calculus Lecture. I'm going to call this 1.3a to try to match the sections in the textbook. So we're in section 1.3 and A means the first lecture from that section. And we'll be working some problems from page 64. All right, so this lecture I'm going to title The Limit Laws. And this is the easiest way to calculate limits. It's we'll call it plug-in limits, where all you do is you don't really have to do any algebra to solve it. You just plug a number in. But the official word for this is direct substitution. Alright, but a lot of times people call them plug-in. Alright, so here are our limit laws. First of all, we'll have a condition if the limit as x approaches a of f of x is equal to L, and the limit as x approaches a of g of x, so another function, is equal to m. Right, then these laws are really in a lot of ways just common sense. Okay, so the limit as x approaches a of f of x plus or minus g of x is just going to equal to L plus or minus m. All right, so you can just string those limits together like that. The limit as x approaches a of f of x times g of x, what do you think it'll be? Well, it's going to be L times m. All right, so again, kind of common sense. The limit as x approaches a of f of x over g of x, take a guess what you think that's going to be. Well, it's going to be L over m. All right, the limit as x approaches a of some constant times f of x, you just take that constant and multiply it by the limit of f of x. So that's just going to be c times L. All right, and if it was g of x, it'd be c times m. All right, and on this one, by the way, we do have to put a condition: m cannot equal 0. All right, on the one previous. All right, the limit as x approaches a of c. So this is just a constant like 5 or 7 or 10 or whatever. All right, you don't have the function in there. Well, there's nothing to plug in, is there? So it's just c. All right, I'm going to put the next one over here. The limit as x approaches a of x to the n will just be a to the n. We just plug a in for x. All right, and another way to say that more broadly, the limit as x approaches a of f of x would be f of a. We're plugging a in for x, so f of a. All right, so I'm about to erase all this if you need to pause. Okay, let's say we have a fraction. a rational expression. The limit as x approaches a of p of x over q of x. All right, so this doesn't really relate to this initial condition here. Is just going to be p of a over q of a, as long as q of a does not equal 0. All right, let's get into some trig, and we'll go over the unit circle in a minute and remind you of that. Let's say we have the limit as x approaches a of sine x. That's going to be sine a. Okay, we're plugging in a for x. And this is also going to be true for our other 5 trig functions. So what are those? All right, that would be cosine, tangent, cosecant, cotangent. And you remember the one that goes with cosine? Secant. All right. So let's do an example here. This one isn't from the book. Let's evaluate the limit as x approaches -2 of x minus 5 over 2x squared plus 3x minus 10. Okay, so what you're going to do is just plug -2 in for x. So that'd be -2 minus 5 over 2 times -2 squared plus 3 times -2 minus 10. So that's going to be -7 on top, and on bottom -2 squared is 4, so it'd be 8 minus 6 minus 10. So -7 over -8, which is 7/8. So just easy. That's the direct substitution, plugging right in. All right, you need to, if you haven't done it yet, pause the video and print out a unit circle. So you're going to need to have that with you. Get one out here and just remind you how to use the unit circle. So remember, it is cosine and then sine. Okay, so the cosine of pi over 2, remember pi over 2 is radians, cosine of 90 degrees is 0. The sine of pi over 2 is 1. Now in calculus we usually use radians almost exclusively, so you have to get back used to using those. So if you want to know the cosine of pi over 6, it's root 3 over 2. Sine of pi over 6 is 1/2. Okay, and then it tells you which ones are positive and which ones are negative in each quadrant. Remember, quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right, so the sine of 7 pi over 4, negative root 2 over 2. Okay, and we also had an acronym A, S, T, C. All are positive in quadrant 1. Sine and cosecant's positive in quadrant 2. Tangent, cotangent positive in quadrant 3. Cosine and secant positive in quadrant 4. But on this sheet, and you get this for the test, it tells you what's positive in each quadrant right on here. So you don't even have to remember the ASTC acronym. Okay, so we're going to use that unit circle and do a little bit of a refresher for trig, the trig identities real quick. So you need to remember that tangent is equal to sine over cosine. Right, you're going to want to remember that. Secant is equal to 1 over cosine. So if you know cosine and you want to get secant, you just flip it. All right, cosecant is 1 over sine. cotangent would be cosine over sine. All right, and cotangent is also 1 over tangent. So we call these the reciprocal trig functions. Secant is the reciprocal of cosine. Cosecant's the reciprocal of sine. Cotangent's the reciprocal of tangent. All right, let's work some examples from the book. So our first one is example 22 from page 64. So if you'll open up to page 64, 22 says evaluate or find the limit as x approaches 1 of sine pi x over 2. So the first thing you always do when trying to find a limit, now it may not work, but in this section it works, plug in 1 for x. So that's just going to be the sine of pi over 2. Well, look at your unit circle. The sine of pi over 2, we already talked about that, is 1. All right, let's look at example 26 on page 64. That's the limit as x approaches 5 pi over 3 of cosine x. So we're going to plug in 5 pi over 3 for x, so cosine 5 pi over 3. Look at your unit circle. 5 pi over 3 is over there in quadrant 4. Cosine's the first one, so that's going to be 1/2. So far, so good, right? All right, let's look at example 28. That's the limit as x approaches 7 of the secant of pi x over 6. Okay, let's plug 7 in. So that would be the secant of 7 pi over 6. Now your unit circle doesn't tell you secant, but it does tell you cosine. So let's find the cosine of 7 pi over 6, and then we can just flip it. So the cosine of 7 pi over 6 is negative root 3 over 2. Therefore, the secant of 7 pi over 6 is going to be negative 2 over root 3. Now, the back of the book may force you to rationalize that. So how do you do that? I don't really require you to rationalize on the test, but the back of the book, when you look at the answers, may do this. So we just are going to multiply by a clever version of 1 to try to get rid of the radical in the denominator. So multiply it by root 3 over root 3. So that's going to be negative 2 root 3 over 3. Now, I personally don't find that to be a better situation than negative 2 over root 3, so I'm not a big fan of that. But you may have math teachers in your future that force you to do that, so I wanted to remind you how to rationalize. All right, we'll keep going. Okay, next example is number 30. All right, and that one says, I'm going to pull this into view, says use the information to evaluate the limits. So we have the limit as x approaches c for f of x is equal to 3/2. So I'm going to go ahead and write that down. And then the limit as x approaches c for g of x is 1/2. So part A says to find the limit as x approaches c of 4 times f of x. So that's just going to be 4 times 3/2. which would be 12 halves, or 6. All right, and then part B, we want to do limit as x approaches c of f of x plus g of x. That's going to be 3 halves plus 1 half, 4 halves, which is 2. And then C, we have the limit as x approaches c of f of x times g of x. So we just multiply the two. 3 halves times 1 half, which would be 3/4. And then part D, the limit as x approaches c of f of x over g of x would be 3 halves over 1 half. So that's the same as 3 halves times, flip the bottom, right? 2 over 1. The 2's cancel, and you have 3. All right. So let's do one more example, and this lesson will be complete. Our last example is number 34. So that one has 2 parts. The first part, we're going to read the graph. Let's see, the first part, A, we want to find the limit as x approaches -2 of h of x. All right, and then part B, the limit as x approaches 0 of h of x. Well, on these, you can just read the graph, since they gave you the graph. So you can see as x approaches -2, so we're down here where this point is. What's the y value? It's -5. And then for part B, as x approaches 0, what's the y value? Right? It is -3. All right, so the answers are -5 as x approaches -2, and 0 would be -3. Now, the second part of the question says, when possible, and this is some foreshadowing, you have to be having to do a lot of this pretty soon. When possible, identify 2 functions that agree at all but one point. So we have, they tell us the function is h of x is equal to x squared minus 3x over x. Okay, so that's our function, but we could reduce this function. How about if we factor an x out of the top? So that'd be x minus 3 over x. And then we can cancel those x's as long as x does not equal 0. And that's x minus 3. So the 2 functions that agree at all but one point, and that one point is 0, they're not the same at 0, would be x squared minus 3x over x and x minus 3. Okay, so your homework for this section, right, starts on page 64, and you can do 5 through 35 odd. All right, and I will make a video that's a solutions video for this homework, so give it a try. Check the answers in the back of the book. All the odds are in the back of the book, and then you can look at the ones you had trouble with from my video. All right, have a great one. See you next video.